Hello students and welcome to Diksha Vedantu Foundation channel, and you are watching midterm score booster series. Here we are discussing each and every chapter that is there in your midterm syllabus. So here today we are going to discuss the last chapter for your midterm, electricity. Okay, I hope you will enjoy this session. Here we are going to discuss each and every important question, some pattern questions from this chapter and also their answers. Okay, so without any delay, let's start with today's lecture. So first we will learn about the basics about this chapter. So electric current is given by I equals to Q by T. And then there are circuits. In circuits there are two types of circuits. One is open circuit when current is not flowing, and one is closed circuit when current is flowing in it. Now next is Ohm's law. Ohm's law is basically given by V is equal to IR. Okay, R is resistance of the circuit. Also R can be written as rho L by A. Here rho is called resistivity of the material. It depends on the material and temperature. L is length of the material, A is the area of the material. Right, now let's look into the next part. Connection of resistances. There are basically two connection of resistances. One is series connection. Okay, in series connection R is equal to R1 plus R2 plus R3 plus etc. And in this case, when you want to increase the resistance, you have to use series resistance. And in parallel resistance, the equivalent resistance is given by 1 by R equals to 1 by R1 plus 1 by R2 plus 1 by R3, and in parallel combination resistance decreases. Okay, in fact, in parallel combination, the equivalent resistance is less than that of the lowest resistance connected in this case. Okay, so if suppose you are connecting 1, 2, 3 ohms, 1 ohm, 2 ohm and 3 ohm in parallel combination, then the equivalent resistance will be less than even 1 ohm. That is the smallest resistance in that case. Now let's move on to the last part where power is being discussed. In power, we know Joule's law. Joule's law is basically I square RT, the heat developed in the circuit. Okay, also sometimes it is written as VIT. Okay, I is capital because I am writing current capital, so I should be capital. Okay, VIT, and power is given by I square R or only VI. Okay, Vodafone Idea. Now application of this, there are multiple applications. I have only noted two applications. One is heating elements. So if you are using immersion heater or any room heater in your home, possibly they are using this Joule's law. Also the fuse that is used in our household to protect any expensive devices, that also based on this Joule's law. Now if you want everything, all the notes, all the lecture notes, including the problems that we are going to solve in today, and you want to download the PDF of that, it is available in our website. You can click on the link given in the description and download the PDF absolutely free of cost. Okay, so everything will be provided by us. You can download it from the website. Now let's start with the first problem. What is the first problem? A cell, a resistor, a key and ammeter are arranged as shown in the given circuit diagrams. The current recorded in the ammeter will be. So now they have given you three circuits. Okay, and they have asked you in which case the current will be maximum in 1, maximum in 2, maximum in 3, the same to all the cases. So now first let us understand the circuit combination in this case. So plus of the battery is connected plus of the ammeter, and negative of the battery is connected to the negative of the ammeter. In this case also plus of the battery is connected plus of the ammeter, and negative of the battery is connected negative of the ammeter. Similarly here also plus is connected to the plus, minus is connected to the minus. And if you see all the cases, the resistances are same. Here also R, this is also R, this is also R. So all circuits have same resistances, same battery, same ammeter. Okay, and every cases key is on. Okay, this means key is on, and if this is there, that means key is off. Okay, this is all the cases key is on, all the cases same resistance, all the cases the ammeter is connected properly. That means there is no way the current will be different, current will be same in all the 3 combined cases. So correct answer is same for all cases. So correct answer should be D. It does not matter how you connect the ammeter, as long as circuit is complete, as long as all the elements in the circuit are same, okay, the current should remain the same. Now let's look into the next question. Now an assertion reason question. Electrons move from lower potential to higher potential in a conductor. Correct statement. Electrons move from lower potential to higher potential, whereas we consider the flow of current from higher potential to lower potential, that is the opposite to the direction of electrons, right? Now another reason is given as dry cell maintains electric potential difference across the ends of a conductor. Now dry cell maintains a electric potential difference across the ends of the conductor, that is also correct, but is it the reason for this? Is because dry cell is maintaining a potential difference, electrons are moving. Electrons can move even if it is not a dry cell, if it is any other cell, if it is an electrolytic cell, even if it is a single electron also, it can move from lower potential to higher potential. So nothing is there as reason. Both of the statements are correct, but this reason is not actually a reason. So correct answer is both assertion and reasons are correct, but reason is not the correct explanation for the assertion, right? So this is the correct answer. Now let's move on to the next question. A current of 1 ampere is drawn by a filament of an electric bulb for 10 minutes. Find the amount of electric charge that flows through the circuit. So here they have told you the current is 1 ampere and it is on for 10 minutes, and they have asked you to find the amount of charge in the circuit. So we know that I is equal to Q by T. So Q should be equals to I times T. Now remember that here current is given 1 ampere and time, you need to convert time into seconds. So for 10 minutes you have to convert it into seconds. So 10 minutes means 10 times 60 seconds, that is 600 coulomb. Okay, 600 coulomb charge is flowing through the circuit. So this is the answer for this simple question. Okay, 2 marks question. Answered, you got 2 marks. Now let's look into the another question. Okay, so before I proceed, I have to answer the homework questions that I gave in our previous lecture from human eye. So let's look into those answers first. Which of the following phenomena contributes significantly to the reddish appearance of the sun at sunrise or sunset? Very interesting question. Dispersion of light, scattering of light, total internal reflection, reflection of light from the earth. So basically this is the reason, scattering of light. Scattering of light, if you remembered our class where we discussed, because of the scattering we observe redness of the sun. Okay, dispersion of light is the reason behind rainbow, one of the reason behind rainbow. Now next question. The bluish color of the water in the deep sea is due to the presence of algae and other plants found in water, the reflection of sky in water, scattering of light, absorption of light by the sea. So I also informed you, I told you that the ocean appears blue because it reflects sky. Okay, and sky appears blue because of the scattering, right? So the bluish color of the water in deep ocean is basically due to the reflection of the sky. If the water is clean, it will reflect the sky and you will see blue color. Now next question. Draw ray diagrams in each of the showing myopic eye and hypermetropic eye. So I think I have drawn that diagrams in yesterday's class. Also these 2 diagrams are available in the book, so I am not drawing this. A person needs a lens of power minus 4.5D for correction of her vision. So the power is minus 4.5D. Okay, what kind of defect the vision is she is suffering from? The suffering, she is the power is minus. So minus means she is using a concave lens. Concave lens means it is a myopic eye. So the disease she is suffering, or the defect, not disease, you cannot call them as disease, this is the defect, eye defect, the defect she is suffering from is myopia. What is the focal length of the corrective lens? We know that focal length and power is given by P equals to 1 by F, where F is in meters. So power is given minus 4.5. So F is minus 1 by 4.5. Now this is in meters. So to convert it into centimeter, what we can do, we can simply multiply it with 100, okay, and then we can cancel it. 45 divided by 100, it will be around 22, okay. So it will be nearly 22 centimeter, okay. You can find the decimals if you have time, but approximately it is 22. Now what is the focal length of the corrective lens? That is done, 22 centimeter. What is the nature of the corrective lens? Nature, obviously power is negative, even focal length is negative, so that means it is a concave lens. Okay, the nature is concave lens. Simple question. So it's a kind of case based question, you can consider it, okay. Even though it is mentioned short answer type, it is not super short answer type, it can consider it a long answer time only. Now let's look into the next question. A student sitting at the back of the classroom cannot read clearly the letters written on the blackboard. What advice will a doctor give to her? Draw a ray diagram for the correction of this defect. So the student cannot read clearly the blackboard, that is something is which is far away, so that is also myopia, okay. And what advice will a doctor give it to her? Wear lenses. What type of lenses she needs to wear? She needs to wear a concave lens, okay. Draw a ray diagram for the correction of this defect. So ray diagram will be eye, okay. Initially the rays coming from, this is eye lens. It is a ray diagram, right? So you don't need to worry too much about it. So initially the rays are falling on the lens like this, okay. Then it will diverge slightly. You need to adjust the divergence so that it actually falls on the retina, lens, sorry, okay. So what we will do, we will keep the rays very close to the, so this is the lens, right. We will keep the rays close to the eye. So after divergence, everything will fall and then they will converge in the retina. So this is the basic ray diagram, okay. This is the myopic eye. Now you can see all the distant objects. Initially when the distant objects are coming, they are focusing before retina, that's why we are not able to see. So for example, I have myopic eye, so I wear these glasses. This is basically a concave lens, so doctor suggested me to wear concave lens, and this is how my eye is being corrected. So now I can see clearly, okay. Now next question. Before we move on again, you can download the PDF including the solution for yesterday's class, today's homework, today's all questions. You can go to our website and download the PDF, the link and the video link, everything will be provided in our website. You can watch anytime you want. You can download the PDF and save it in your computer, and you can study from them anytime you want. Now let's move on. Now let's look into Ohm's law, okay. Very important topic, Ohm's law. At least one long question will definitely come from this chapter, from this part, okay. Let's look into the long answer type question from one of the previous year questions. The potential difference across two ends of a circuit component is decreased to 1/3 of its initial value. So what is the thing they are saying? The potential difference is decreased to 1/3 of the initial value. So suppose initial potential difference was V, now the potential difference is 1/3 V, okay. While its resistance remains constant. So resistance initially was R, second time also R. what change will be observed in the current flowing through it. So initially what was the current? Suppose the current was I, then from Ohm's law we can write V is equal to IR. Now next time suppose the current is I dash, from Ohm's law we can write V by 3 is equal to I dash R. Okay, so now let's compare it. Okay, divide both sides, so we will get V divided by V by 3 is equal to IR divided by I dash R. Okay, RR cancels, these 3 will go up, VV cancels, so we will get 3 equals to I by I dash. Okay, so I dash will be I by 3. Okay, this will go up, this will come down, so cross multiplication. Or for simplicity what you can do, you can write one more extra step, that is 3I dash equals to I. If you are confused, you can write this step intermediate steps or intermezzo. Okay, then you can find I dash equals to I by 3. Okay, name and state the law which helps the answer this question. Obviously the law that we are using is Ohm's law. The law we are using Ohm's law, and the statement is if temperature and other physical conditions remains unchanged, the current through a circuit is directly, not circuit, you can write it as a conductor. Circuit is a big thing. Is directly proportional to the potential difference across the conductor. Right? So this is the Ohm's law. You have to remember it by heart. You should study it such a way that when your grandkids ask you, Anna, what is the Ohm's law, you should be able to answer this. Okay, you can remember it by memorizing it 2-3 times or by understanding. Okay, so first of all, temperature and other physical constant, that should be remain constant. These are the two constants of Ohm's law. Sometimes very rare they ask what are the constants of Ohm's law. So the constants of Ohm's law are temperature and other physical constants. Other physical constant means, suppose you are sending current through a circuit, suddenly the circuit melts, okay, or the state of change is state is changing, or the wire is getting lengthier, so it is expanding. So these things should not happen. Everything should remain constant. The temperature should remain constant. The physical size and shape of the conductor should remain constant. So in that case, current is directly proportional to the current. That is the Ohm's law. Okay. Now there is a second part to this question. Draw a schematic diagram of a circuit consisting of a battery of 4 1.5 volt cells, a 5 ohm resistor, a 10 resistor and a 15 ohm. They are all ohm resistor. Okay, so they are all ohm. Ohms is missing somehow. 5 ohm resistor, 10 ohm resistor and 15 ohm resistor. Okay, and plug a key. All the connection connected in series. Now find current number 1 electric current passing through the circuit and the potential difference across the 10 ohm resistors when the plug key is closed. So first, what is the circuit diagram? What are the resistances? We will draw the resistances first. A 5 ohm resistor. Okay, then there is a 10 ohm resistor. Then there is a 15 ohm resistor. Okay, 5, 10 and 15. Okay, these are the 3 resistors, and a battery of 4 1.5 volt cells. So battery means there are multiple cells, each of them are 1.5 volts, 1, 2, 3, 4. So this is the, each of them is 1.5 volt. Okay. Now there is also, we have to connect a key, right? Now there is a key. Now key is closed. When the key is closed, current will flow. When the key is open, circuit is open, no current will flow. So now what they have asked you, find the electric current passing through the circuit. So what is the current passing through the circuit? First of all, we have to find what is the total potential difference. What is the total potential difference? So here 4 cells are connected in series. So connected in series means their potentials will be added, 1.5 plus 1.5 plus 1.5 plus 1.5. Simple. So it will be 4 times 6 volts, right? Since everything is same, you can multiply 1.5 with 4 also. That will give you the potential difference. So 6 volts is the potential difference. Next is, these all 3 resistances are connected in series. So the equivalent resistance is basically 5 plus 10 plus 15. So 5 plus 15 is 20, 20 plus 10 is 30. So the resistance is 30 ohm. Okay. Now most of the cases what I have seen is they are asking series based questions. Parallel based questions are mostly asked in short answer type questions and in objectives, but in your midterm question paper, maybe they will ask some questions based on parallel. So practice parallel as well. But since I am focusing on most of the students, most of the schools, so in that case series is more important than parallel, because it is easy, and for your standard, for your class, series is considered optimum. Okay, parallel is slightly difficult. So in case also parallel they are asking, they will mostly give you 2 resistors only in parallel combination. Okay, now let's find the current. So current is V by R. V is equal to IR. So I is equal to V by R. So V is 6 volts, resistance is 30. So it will be 1 by 5 ampere. So 1 by 5 ampere or 0.2 ampere or 200 milliampere, whatever you want. 200 milliampere, I prefer 0.2 ampere. Okay, now next they have asked you the potential difference across the 10 ohm resistance. This is very, very important. This is very important. Potential difference across 10 ohm resistance. Now current in the circuit is same. They are all connected in series. So the same current is passing through 5 ohm, same current is passing through 10 ohm, and same current is passing through 15 ohm. Okay, so the potential drop across 10 should be the resistance 10 times the current passing through it. Resistance potential drop across any resistance individually obeys Ohm's law. This is very important. All the resistances, maybe it is connected in parallel, maybe it's connected in series, does not matter. All the resistances individually obeys Ohm's law. There are certain materials, they don't obey Ohm's law, they are called non-ohmic conductors. We are not discussing that here. Only thing is, whatever resistances are there, if they are connected in a circuit, okay, individually each and every component should obey Ohm's law. This is very, very important. So when we are considering the entire circuit, we will consider the resistance of each and every, we will consider the equivalent resistance. We will consider equivalent potentials. Okay, but when we are considering any single part, if we know the current, we can still find the potential difference by using this formula. So 10 times 0.2 volts, total volts, unit is volts, so it will be 2 volts. Now remember to use the units. When you are calculating the potential, it should be volts. When you are calculating the current, it should be in ampere. When you are calculating the resistance, it should be in ohm. These are the basic units, so you should be familiar with these units. And if you still have any doubts, mention in the comment below what doubt you have. Okay, when I have seen many students solve up to this point. This point is easy. Up to this point many students find it easy, but from here on they are confused what to do. A single part is given. Don't worry, if you have calculated up to this point, your 90% work is done. Only thing you have to do is take the resistance, whatever resistance they have given you, okay, and then multiply with the current that you have found. Okay, so this is a very typical numerical. Also remember that your question standard is getting difficult every year. During pandemics, your seniors, they were given easier question papers, they scored a lot of marks, but now they are coming back to the old ways where question paper is standard. Okay, some easy questions, some difficult questions mixed all together. So this question in my opinion is not very easy, because you have to draw the diagram, you have to solve the voltage, you have to find the voltage, you have to find the resistance, then you can find the current, then you can find the resistance. This is a very important, but it is from one of your previous year questions. So if you are thinking this is a very difficult question, actually it is given to you in previous year questions. So they might change the values, they might change the structure of the question, but what you have to do, you have to do the same thing. Okay, now let's move on to the next question. Ohm's law. Study the IV graph for 3 resistors of 3 samples of nichrome wire of resistances R1, R2 and R3 respectively. Which of the following is true? So they have given you 3 resistances R1, R2, R3 and their IV graph. Now remember that if these 3 resistances are different, that means they have different IV characteristics, IV graphs, that means these resistances are not same. This much is clear. If they are having only one graph, suppose all the resistances are showing only one graph, R1 is also along this, R2 is also along this, R3 is also along this, in that case all the resistance will be equal. Otherwise all the resistances are not equal, so definitely we can rule this one out. Okay, now what else? Since R2 is in the middle of R1 and R3, okay, R2 is in the middle of R1 and R3, R2 cannot be the biggest. So R2 cannot be the biggest, so we can cross this one out also. So what we have to do, we have to find which one is greater, R1 is greater or R3 is greater. So as you can see, the greater than symbol is towards R1, so that means R1 is big brother or R2 is smaller than that. So R2 should be in the middle, right? So in both cases R2 is in the middle, okay, R1 or R3, who is greater, that one we have to find. So for that what we have to do, first we have to consider a constant voltage. Say this is a constant voltage we are considering. Okay, this is a constant voltage we are considering. Now from here what we will do, we will draw a perpendicular. We will draw a perpendicular. Okay. You can do it like this also. Now this is the perpendicular that we have drawn. So that means along this line voltage is constant. Okay, voltage is constant, the constant value is this. Okay, now we will check how the current is changing for this constant voltage, and then we will use our knowledge V is equal to IR. Okay, so what is the current here? Suppose this current is I1, this current is I2, this current is I3, right? Now tell me which current is greater. From this graph, which current is greater? So this is a y-axis, this is x-axis, right? I hope you are familiar with coordinate system, you are familiar with the graph system. So as we are going up, the value increases. As we are going right, the value increases for x-axis. For x along the right, value increases. For y along up, value increases. And this point is 0, 0. This is called origin, 0, 0. So both values are 0 at this point. Now here we can clearly see that I1 is greater than I2 is greater than I3. Right? This is clear to us, because if suppose this is 1, this should be 2, this should be 3. So this is clear to us that I1 is greater than I2 and I2 is greater than I3. Now, which one has higher resistance? We know that resistance is basically V by I, right? Or resistance for constant V resistance is inversely proportional to current. Resistance is inversely proportional to current. So higher the current, lower the resistance. Higher the current, lower the resistance. Lower the current, higher the resistance. So from that we can see that R3 is highest, it is the most highest, and R1 is the weakest. R1 is weakest, that is smallest. R1 is highest, R1 is smallest, and R2 is in between them. So R3 should be the highest value. So the correct answer is option C. Very, very interesting, and this is also from one of your previous year question paper. So if you are thinking, okay, this is also too high for me, you have to answer such questions. Okay, even it is an MCQ, it is not so easy to answer. You have to think and then only you can answer. Now let's move on to the next part. The resistivity does not change. Now we are talking about resistivity. If you remember at the beginning of the lecture, I told you resistivity depends on three things. Resistivity depends on only two things. Resistivity symbol is rho. It depends on the material and it depends on the temperature. It is independent of everything else. Okay, if you change the material, that is if you are using iron, instead of iron, if you think, okay, I want to use copper, or instead of copper I want to use silver, or instead of silver I want to use platinum. So based on what material you are using, okay, material means metal basically. Okay, what material you are using, that changes. Some cases non-metal also has conductivity, for example graphite. Okay, that's why, or gas carbon, that's why we generally call it as material. Okay, so the material is changed, obviously resistivity will change. The temperature is changed, obviously resistivity will change. The shape of the resistor is changed. It does not depend on the shape of the resistor. Resistance depends on the shape, but resistivity does not. Resistivity is constant. So here you have to answer the wrong option, that is which one is wrong, which one is incorrect. So shape of the resistor is changed, resistivity will not change, resistivity will remain constant. So this is the correct answer. In this case they have given material and temperature both, so you can guess that the correct answer should be this. This is the easy guess question. Even though the question is not direct, you can guess the answer. Now let's look into the next question. What is the electrical resistivity in series electrical circuit comprising a resistor made up of a metallic wire? Ammeter reads 5 ampere. Okay, the reading of the ammeter decreases to half when the length of the wire is doubled. Why? So first of all, what is electrical resistivity? So electrical resistivity, to define electrical resistivity is basically a constant. R is equal to rho L by A. Now remember that resistivity sometimes is called specific resistance. It is another term for resistivity. It is same as resistivity. Okay, some students sometimes get confused. What is specific resistance? It is nothing but resistivity. You need to remember this. Okay, resistivity and specific resistance are same. Okay, now we know that rho is equal to L by A. Now if we take L is equal to 1, A is equal to 1, then rho becomes R. So resistivity of a material is the resistance of one unit length and unit cross sectional area of a material. The resistance of unit cross sectional area and unit length of a material is called its resistivity. Simple. Okay, this is how you can define resistivity. Now let's look into this problem. So what they have said that ammeter reads, so in a circuit there was some resistance was there. Okay, ammeter was there. Okay, and there was some battery and the current was 5 ampere. Okay, now they have said that the reading of the ammeter decreases to half when the length of the wire is doubled. So when the length of the wire is doubled, the current decreases to half, current becomes 2.5. Now why? Because we know that resistance of a wire is proportional to its length, right? Resistance is rho L by A. So initially suppose the resistance was R1 is rho L by A. Okay, now next resistance is what? Now length is doubled, so that means 2L by A, area remains constant, so basically it is 2R1. So the resistance becomes doubled, that's why the current is now half, right? We also know from Ohm's law, I is equal to V by R, right? So if you increase the resistance, current will be decreased. Now if you increase the resistance by twice as much, the current will be decreased half. Okay, so first of all, to answer this question, you have to mention that the resistance is getting doubled. Either you can use this formula or you can use this formula. Next part, you have to mention Ohm's law, that current is inversely proportional to resistance. Now if we increase the resistance double, if we double the resistance, current will become halved. That's why the current decreases. Okay, you have to mention these 2 points clearly to get full marks. You have to remember that. Now next question, show how would you connect 3 resistors, each of resistance 6 ohm, okay, so that the combination has a resistance 9 ohm. Very interesting question. Also justify your answer. So remember that what you have given, 3 6 ohm resistances. Now first of all, what will happen if you connect them all in series? If you connect all of them in series, then total resistance will be 6 into 3, 18 ohm, right? 6 plus 6 plus 6, or 6 into 3, okay, 18 ohms. What will happen if you connect all of them in parallel? Okay, parallel, in case of parallel, the combination will have even less than that of the 6 ohm resistance. I already explained in the beginning of the lecture that in parallel combination, the equivalent resistance is less than the smallest resistance. In this case, 6 itself is the smallest, so the equivalent resistance will be even smaller than the 6. Okay, in fact in this case it will be 2 ohms. Okay, but so basically you cannot connect them directly into series or directly into parallel. So what you have to do, you have to use some logic, and you have to use certain things into series, certain thing into parallel. And in this case the answer will be, first you have to connect 2 6 ohms in parallel. You have to connect 2 6 ohms in parallel, and then 1 6 ohm in series with this. So how can you answer that? To answer such questions, first of all you have to do some back calculations in rough or in the behind the page. Then once you find what combination is suitable, you write, you have to mention that 2 6 ohms in parallel and 1 6 ohm in series with this. Okay, now if to justify your answer, how can you justify the equivalent resistance in this case? Suppose we have to find the total equivalent resistance and show it is actually equals to 9. So what is the equivalent resistances of 2 resistors in series, parallel? 2 resistors in parallel, you can use old fashioned REQ. Suppose REQ1, we are saying REQ1 because there are multiple combinations, so you can use the old fashioned way. I will teach you one shortcut method as well. So it is also 1 plus 1 by 6, so it will be 2 by 6 equals to 1 by 3. So REQ1 is 3, so the total equivalent resistance is 3 plus 6, that is 9 ohm. So this is the justification. In the justification, you have to show the final resistance is actually equals to 9 ohm. Okay, now how can you do it in shortcut way? So REQ1, when 2 resistors, I am not sure if it was done in your class or not. When I was a student, no one taught me at your class, but yes, I learned it in class 11th, class 12th. Okay, again you will learn that in class 12th obviously. Okay, but till then I am giving you a shortcut trick. In this case, the R equivalent, you can directly calculate R equivalent without using the help of 1 by R. Okay, when this only valids for when 2 resistors are connected in parallel, not for 3, not for 4. Only when 2 resistors are connected in parallel, you can directly use R1 R2 divided by R1 plus R2. This is the shortcut formula to calculate the resistance of 2 resistors connected in parallel. And in your class mostly 2 resistors will be given. If more than 2 resistors are given in parallel, then you have no option, you have to use this method. Okay, otherwise you can use direct method for this. For example, let us now use the shortcut method and try to find ReQ1. It is 6 times 6 divided by 6 plus 6. So it is 36 divided by 12. So it is 3 ohm. Now tell me which one is simpler, this method or this method? Okay, mention that in the comment below. So this is the equivalent resistance, this is your justification, and you will score full marks out of this. Now let's move on. In the given circuit, calculate the power consumed in watts in the resistor 2 ohm. So in the given circuit, you have to find the power consumed in this 2 ohm resistance. So first of all, what we have to do, we have to find the current in this circuit. What is the current? Total current in the circuit. Now whatever current flowing in this circuit will be same for both the resistors. Then we can use the power consumed formula. So first of all, what is the equivalent resistance? Equivalent resistance, both resistance are in series, 1 and 2 are in series. So equivalent resistance is 3 ohm. Simple. Now what is the current? Current is V by R. V is 6 and R is 3. So current is 2 ampere. So you have calculated the current. Now what we have to do? We have to find the power consumed in watts in the resistor 2 ohm. So power consumed in 2 ohm is I square times R, right? Power is I square R only. You don't use the time t, right? So I is 2 ohm. It is same for all resistance, and in this case the resistance is 2. So it is 4 times 2, that is 8 watts. So 8 watt power is consumed in this 2 ohm resistance. Simple. Okay, you have to first find the current, step by step process. First you have to calculate the equivalent resistance of the circuit. Next step you have to find the current in the circuit. Next step you have to use the I square R formula. Okay, for parallel the formula is little difficult, little different. Okay, in parallel voltage remains same, so you have to find the voltage. If the voltage is already given, then don't need to worry. Okay, you can simply use V square by R. That is another formula that you can use. Okay, now let's move on. We know that H is equal to I square RT. Sorry, I have already, the answer is visible here. The name, we know that I square H is equal to I square RT. This is Joule's law. Right? Now name 2 properties of heating elements. This is used in heating elements. Okay, that question was a little longer. There was a long statement was there, but I have only used the basic crux of the question. Name 2 properties of the heating elements. Okay, the element should be easily transfer heat that is generated. Okay, next is the element should not melt at high heat. So these are the 2 properties of heating elements. So if you are using any heating element in your room, if you are watching this video from northern part of India, from Delhi or Punjab or Haryana, there you use heating element in your home. Okay, and especially during winters, so the heating element that you are using in your home, okay, that the coil that is being used inside, they should transfer the heat quickly towards their surroundings. Second was what? Second is, if they melt, obviously they will break. So they should not melt, they should have a high melting point. Okay, this is one more point, so high melting point. Okay, they should not melt easily. Next is name 2 properties of electric fuse. Electric fuse is almost contrasting to that of heating elements. First of all, the resistance of the fuse should be very low, so that the current, if the current is passing beyond the limit that is being specified for, okay, it should get a very high current through it. The fuse should melt if high current is passing through it. Okay, so if the heat is generated, it should melt. So in case of heating element, they should not melt. In case of fuse, they should melt. This is the basic difference between heating element and electric fuse. Now, part of the same question, part 2 of the question, power of an electric heater is 1100 watt. if the potential difference between two terminals of the heater is 220 volt, find the current flowing in the circuit. What will happen to the electric fuse of rating 5 ampere is connected in this circuit? So first we have to answer this, find the current flowing in the circuit. Now we know that it is given that H is equal to I square RT, right? Or in other words, we can take IR, one IR, another I is there and T, and we can mention this as VIT, vitamin. Remember that the heat generated in a electric circuit is actually a vitamin, VIT. Okay. Now power is heat generated per unit time. Power is heat generated per unit time, that is equals to VI. Vodafone idea, right? Now here power is given 1100, so you have to use those values. Power is 1100, V is 220 volts, and you are supposed to find the current in this circuit. So what is current? Right? So 0 0 cancels, 2 55, 2 is, sorry, it is not 2, it is 11. 2 11s are 22, okay, 2 55s are 110, 11 5s are 5. So the current is 5 ampere. Okay, so the current flowing in this circuit is 5 ampere, and if you connect an electric fuse of 5 rating connected to this circuit, okay, nothing will happen, the circuit will function as usual, because the current that is flowing in this in this heater is equals to 5 ampere. But if somehow the heater malfunctions and the current increases more than 5 ampere, then it will stop working. But in this case nothing will happen, the heater will continue to work as normal. Okay, but if in this case if they ask you what will happen if we add 1 ampere fuse in this case, so in that case the current in the heater is 5 ampere, you have connected an 1 ampere fuse, it will burn, okay, and it will stop working. So you have to remember when you have to answer what. Okay, if they ask you 10 ampere fuse is connected, then you have to mention the maximum current passing through the heater is 5 ampere, so it should work properly, okay, without any disturbances, right? So these are the variations of this question. Now let's look into the homework. So what is the minimum resistance which can be made using 5 resistors each of 1/5 ohm? So what is the minimum resistance? Which combination we will use? They have directly given you minimum resistance. Remember the topic, remember the lesson, and try to answer it and mention the answer in the comment below. Now let's look into the next question. A cylindrical conductor of length L and uniform area of cross section A has resistance capital R. Another conductor of length 2L and resistance capital R of the same material has area of cross section. Now they have given you the formula, I already told you, okay, R is equal to rho L by A. So in this case they have given the resistances and they have given you length, and they are asked you to find the area between first and second case. Okay, simple question. Now here is a circuit based question. Okay, B1, B2 and B3 are, so B1, bulb 2 and bulb 3 are 3 identical bulbs connected as shown in the figure 12.8. So this is 12.8 figure. Okay, when all 3 bulbs glow, a current of 3 ampere is recorded in the ammeter A. Okay, so when all 3 bulbs are glowing, this is glowing, this is glowing, this is glowing, the current recorded in the ampere is 3 ampere in this ampere. Okay, now what happens to the glow of the other two bulbs when the bulb B1 gets fused. Suppose this bulb B1 is fused, then what will happen to these two bulbs? Okay, first of all you have to identify what type of connection it is. It is a series connection or parallel connection. Then you should know what happens if the bulbs are connected in series and one bulb is fused. What will happen if one bulbs are connected in parallel and one bulb is fused. So these are the basic knowledge that you have to apply. What happens to the reading of A1 and A2 and A3, okay, and A when bulb B2 gets fused? Simple question. Okay, another simple question: how much power is dissipated in the circuit when all three bulbs glow together? Okay, this is also very important question. Current is given, voltage is given, no matter the resistances of the bulbs. Resistances of the bulbs are not given, but you can use the formula P is equal to VI, and I is given, V is given. You can calculate the power dissipated. Okay, another important question. This is a very typical questions. Now another long answer type question. A current of 1 ampere flows in a series circuit containing an electric lamp and conductor of 5 ohm. When connected to a 10 volt battery, calculate the resistance of the electric lamp. Okay, now if the resistance of 10 ohm is connected in the parallel with this series combination, what change if any current flowing through 5 ohm conductor and potential difference across the lamp will take place? Give reason. So you have to do mathematical analysis and then you have to answer this question. Okay, typical question. Another long answer type question: find the following in the electric circuit given figure. Okay, I think figure is missing in this case. I will provide the figure. If you download the PDF, I will give the figure there. Now, if you are currently studying in class 10th and if you are thinking what should you focus in your class 11th and 12th, remember that anything without focus is better than focused mind. Okay, so if you are not sure, then first of all you have to attempt Diksha Scholastic Aptitude Test or DSAT. Here there will be a 1 hour lecture. After the lecture is over, you will be given a question paper, MCQ based question paper, aptitude test that we are calling. Once your aptitude test is over, based on your result, based on your aptitude result, okay, there will be a free counseling, one-on-one free counseling. Okay, and also if you score well in your DSAT exam, you can take admission into Diksha colleges and take up to 90% scholarship. Okay, so why are you waiting? What are you waiting for? Go and register for DSAT today. Okay, there is a link given in the description. You can go there. You can just enroll your names, your email and phone number, and our representatives will contact you and be in touch with you, and they will inform where the DSAT is happening, when the DSAT is happening, and you can take this opportunity and study at a very less and very cheap way in our Diksha colleges, PU colleges. So don't wait, go register today. Now all the lecture PDFs that is being done today and in the previous lectures also, everything is available in our website. You can go to the link given in the description, go there, download the PDF from there, and you can study at your home at your own pace. Okay, so if you like this video, give it a thumbs up, and I will be back with one more video very soon. Thank you.